Good afternoon, friends. The last video we discussed about what is in-way scheduling, what are the types of algorithms, everything we discussed. Now we are going to discuss about the types and in the types we already discussed about FCFS, SJF. What is in-way FCFS? First come first serve and SJF shortest job first scheduling. Next we are going to discuss about that is the arrival time. What is mean by arrival time? The arrival time is nothing but what is the train when you take the that is the railway reservation system. How the at what time the train is reached? What is the arrival time? So the same thing will be applicable for this also if you are using the shortest job first scheduling. So how much time it will take to arrive the destination, to reach the destination, that is called as arrival time. So based on the arrival time, how we are calculating the execution of each and every task. So that is the burst time given to you. Based on the arrival time, we are calculating what is the starting time and what is the ending time using the Gantt chart. Based on the shortest duration, that is the burst time. So here we can't take the execution of the task using burst time. Here based on the arrival time only we need to consider. So arrival time, that is the for P1 process arrival time is 0.0. So the shortest arrival time we should take. 0.0 is the very shortest arrival time. That is next is we need to give the preference for P2, next P3 and P4. So just a little bit is increased 0.0, 2.0, 4.0 and 5.0. So little bit is increased. So based on that, when it is started, when it is ended. So P1 is started here. Again the P1 is not started again. So it is ended here. So it's the time duration is like that. That is 0 to 1. And when you take the P2, when it is started and when it is ending time, everything. So based on that, starting time and ending time. So the based on that only you need to calculate it. Next we are going to discuss about priority scheduling. The priority is that is the based on the job we need to check the which one is executed first in the CPU. We already discussed about what is in way preemptive, non-preemptive, starvation. Starvation is the lower priority process may never execute. So that is the problem. So the problem is of starvation is the lower priority process may never execute. And aging is as the time progress increase the priority of the task. And the priority scheduling, the one problem is given to you for priority scheduling. These are the processor in the queue, A, B, C, 3 processor in the queue. The burst time is already given to you. Here the priority is also assigned. So the first priority given to the process B, and the second priority given to process A, the third priority given to process C. So here the Gantt chart also based on that BAC. So what is the time duration? 1. So based on the burst, it's same procedure you need to follow it for priority scheduling. And next one is average time, turnaround time. The round robin scheduling is so based on the quantum, we are fixing the time duration for each and every task for execution in the CPU. So the quantum is here the fixed quantum is only 3 seconds only it needs to work. Quantum is 4. For example, 3 also we can take for this problem. 3 seconds only each and every task will be executed in the processor. How long time? P1, P2, P taken and again. So till it will reach the 20 per second, it will execute in the processor. How long? How many times? P1. P1 executed first time. After that, it switch over to P2. And after that, it switch over to P3. Again, it switch over to P1. Till that is, it will reach 24 seconds. It will so totally 4 or 5 times it will execute in the processor. And then the next one is this is the preemptive what's that round robin scheduling, the time quantum. So context which actually it is a preemption, we can call it as context switch. So if the higher priority process comes, what happens? The processor automatically switch over to that process. So that is called as context switch. Here the what is in a multi-level queue schedule, multiple queues are there. So here we can execute the task for multiple based on the queue wise. The first queue, system process, interactive editing process, batch process, student process, all the processes are there. Here we are sending the task one by one into the web processor for execution. So based on the here multiple queue system process is nothing but that is interactive process. If you are working in front of the system, interaction, the desktop is an interactive process. If you are using the keyboards for the interaction, so that is called as system interaction basis, interactive. And interactive editing, how we are doing the edition. So we are talking, we want to change that. If you are creating one video, how we are edit the video. For the using with the help of some tool, we are changing the videos. So we can call it task that is the interaction. So batch process, the grouping of process, more than one task executed in the process. We are grouping the task one by one. So we are sending the task one by one into the process itself. Student process, the basic process, we can call it as student process. And the next one is multi-level feedback queue. See, it is different actually when we compare with the other queues. It's totally different. Three queues are there: eight quantum 8, quantum 16, and FCFS. Multi-feedback queue scheduling. See, first we send the jobs into the based on the quantum till 8. So it start executing the task. So if we are not able to complete the task within the 8 seconds, which automatically switch out to the quantum 16. So it can start execute within the particular durations. If not able to complete the task within the 16 second means automatically move switch over to first come first. Like that, the multiple feedback queue scheduling. And so there is real-time CPU scheduling in this hard real-time system, soft real-time systems. That is the hard real-time and soft real-time. Tell me, can you tell me one example, any one of you? That is there's anything we can consider as a soft real-time system, hard real-time system. That is soft real-time systems like we are working in the systems. So that is automatic, it's inbuilt. So that is a real-time system, so we can call it as soft real, hard real-time. The task is serviced by its deadline. Service after the deadline has expired the same as no services at all. So it provides the guarantee as when a critical real-time process will be scheduled. They guarantee only for the process will be given the performance over the so we can service the product within the time duration. We know it will not be on the time duration. Or it's not like that. After the time duration also we can service it and use it. That is the hard and soft real-time tasks. And then real-time priority based scheduling and rate monotonic. This will discuss in the next video. First we'll see the continuation of this video. Next we are going to discuss about deadlock concept. What does mean by deadlock? So what does mean by lock? What does mean by lock? We are locking, we can't execute the task, we locked. The system is locked. We can't execute this further. We can't proceed it further. So some errors are there due to some power cut. Now I am taking video. So due to the net connection, I am not able to continue the video. Some error, some fault. So the P slideshow is not viewed properly. So that is called as locking. So that is suspended. The task is suspended. We can call it as deadlock. So the two processes are trying to access the same resources. So that is called as deadlock. So when we are starting the execution for the process, the resources assigned for each and every process at the same time. But the process is not using the same resources, trying to access the some other resources, trying to just it's trying. So the same resources can't be allocated for the same time for the two processes. The single resource can't be allocated for the two process. So because That time what will happen? The whole system will be locked. And the next one is, so what are the system models? Request, use, release. How we are requesting the process, requesting the resource. We are using the resources. After using the resource, we can release the resource. Request, use and release. And next one is, that is the details. So how we are allocating the resources. So here we are having three resources with the process. We are assigning that is, we are requesting the requesting the resource process P1 is requesting the resource R1. But the resource R1 is already assigned to the process P2. Okay. The process P2 is requesting resource R3, but R3 is what will happen is assigned to already P3 process. So that time deadlock will occur. When the cycle is here, you need to check when the cycle is formed or not. If the cycle is formed, what will happen? The deadlock will be automatically created in that place because we are requesting. But the same resources assigned for another process. So that time what will happen? The cycle will be formed. So it's one condition of deadlock. And so here we need to check whether cycle resource allocation. This is called as resource allocation graph. Here we can check when the cycle is formed or not. When the cycle is formed, deadlock will occur. No cycle, no deadlock. Yes, the another resource is free. Whoever can use, whoever free, people can use that. So when the cycle is formed, you can't. Yeah, this video we discussed about remaining that priority and round robin scheduling, the introduction to the deadlock parts. Okay, this remaining topics will continue in the next video. Thanks for watching. Thank you.